Imagine waking up one morning, you make your coffee, you open the curtains, and the sky is red. Not sunrise red, not beautiful red, wrong red. The kind of red that makes your stomach drop before your brain even knows why. Now imagine that's not a storm, not pollution. That's the sun, and it's dying. And here's the part that should absolutely wreck you. This will happen. Not might, not could, will. The only question is, what happens to us when it does? Let's get one thing straight. The sun isn't just a giant light bulb in the sky. It is the reason you exist, the reason anything exists on this planet. Every breath you take, sun. Every piece of food you've ever eaten, sun. The water cycle, the weather, the seasons, the fact that Earth isn't a frozen rock floating through darkness, all of it, sun. For 4.6 billion years, this star has been burning quietly, consistently, like the world's most dependable engine. But every engine runs out of fuel, and ours, it's already halfway there. Right now, at this very second, the sun is converting 600 million tons of hydrogen into helium every single second. That sounds like a lot, and it is, but it won't last forever. In fact, scientists know almost exactly how this story ends, and once I tell you, you will never look at the sky the same way again. Right now, the sun is in what astronomers call its main sequence phase. Think of it like a person in their prime, strong, stable, predictable. It's been in this phase for about 4.6 billion years. And it's got roughly 5 billion more years left in this comfortable, stable state. 5 billion years. That sounds like forever, right? Here's the gut punch. On a cosmic timeline, that is nothing. And long before those 5 billion years are up, Earth is already in serious trouble. Because here's what nobody tells you. The sun doesn't just suddenly die. It slowly tortures the solar system first. About 1 billion years from now, Earth is still here. The oceans still exist. The continents still exist. But something is very, very wrong. The sun is getting brighter, slowly, incrementally, about 10% brighter every billion years. That doesn't sound like much, but that small increase in solar radiation starts a chain reaction that is irreversible. The oceans begin to evaporate, not all at once, not in a dramatic Hollywood explosion. Slowly, relentlessly, like a pot left on low heat for millennia. Water vapor rises into the atmosphere. And here's where it gets really terrifying. Water vapor is a greenhouse gas. More water vapor means more heat trapped. More heat means more evaporation. More evaporation means more water vapor. It becomes a runaway greenhouse effect, the same process that turned Venus into a 900-degree hellscape. Earth's average surface temperature starts climbing past what any life can tolerate. The oceans, the birthplace of all life on this planet, begin to disappear. Within a few 100 million years, they're gone. Just gone. The planet that once had blue seas shimmering with life becomes a dry, cracked wasteland of rock and dust. No water, no weather, no life. And the sun? It's not even close to dying yet. Now we jump forward, about 5 billion years from now. The sun has burned through most of its hydrogen fuel. And now something extraordinary and catastrophic begins. Without enough hydrogen in its core to sustain the outward pressure of fusion, gravity starts winning. The core collapses inward. But that collapse actually heats up the surrounding layers, triggering hydrogen fusion in a shell around the core. And the energy from that shell, it has to go somewhere. So it pushes outward, violently. The sun's outer layers begin to expand, slowly at first, then faster still. Over the course of hundreds of millions of years, the sun swells to a size that is almost incomprehensible. It becomes what astronomers call a red giant. Picture the sun, the thing that currently appears as a small disk in your sky, growing until it's 100 times larger than it is today. Growing until it swallows Mercury, growing until it swallows Venus, and then Earth. Now, here's where scientists actually disagree, and that disagreement is fascinating. Some models suggest Earth's orbit will slowly drift outward as the sun loses mass, and we'll just barely escape being swallowed. But just barely doesn't mean safe. Because even if Earth survives as a physical object, the surface temperature will reach over 2,000 degrees Fahrenheit. The crust itself will melt. Mountains will flow like wax. If there were any structures left, any remnants of civilization, they would vaporize instantly. Other models say Earth doesn't escape at all, that the sun's expanding atmosphere creates a drag on Earth's orbit, pulling it inward, slowly, inevitably, into the sun itself. Either way, Earth as a living planet is over, long over. But here's where the story takes an unexpected turn. Something almost beautiful happens. After the red giant phase, which lasts hundreds of millions of years, the sun can no longer sustain even this expanded form. It begins to shed its outer layers, a massive wave of gas and plasma, glowing in brilliant colors, blues, greens, reds, expands outward into space at tens of thousands of miles per hour. This is called a planetary nebula, and it is one of the most stunning events in the known universe. From hundreds of light years away, it would look like a glowing ring of cosmic fire, like a painting made of dying light. Scientists have photographed these around other stars, the Helix Nebula, the Ring Nebula, the Cat's Eye Nebula. Each one of those, a star that died, exactly like our sun will. Each one surrounded by the ghost of a solar system. And somewhere in those glowing rings, the remnants of planets, maybe even planets like ours. For a brief cosmic moment, maybe 10,000 years, the nebula glows. Then it fades. And what's left behind? At the center of the fading nebula, where the sun's core used to be, a tiny, incredibly dense object remains. About the size of Earth, but containing roughly half the mass of the original sun. This is a white dwarf. It no longer burns. It no longer fuses. It no longer does anything. It simply radiates the heat it has left. like an ember. For billions, maybe trillions of years, it will slowly cool from white hot to yellow to orange to red, until eventually, in a time frame so long it makes the current age of the universe look like a Tuesday afternoon, it becomes a black dwarf. A cold, dark, dead object floating silently in space. And here's the most haunting part of all. The universe isn't old enough yet for any black dwarf to actually exist. Not one, not anywhere. Every white dwarf ever created is still cooling, still radiating its last light, still holding on to the ghost of what it once was. Now pause. Take a breath. Because I want you to actually feel something for a second. In about 1 billion years, give or take, the last complex life forms on Earth die. Not in a war, not in a pandemic, not by their own hand, just because the star they depended on got a little too warm. And all of human history, every empire, every invention, every war, every love story, every painting, every song, every generation that came before you, and everyone that comes after, all of it existed in the blink of an eye between when Earth got warm enough for life and when it got too warm to sustain it. We exist in a narrow window, a cosmic accident of perfect distance, perfect timing, perfect temperature. We are the universe's brief experiment. And either we do something extraordinary with that window, or we don't. But here's the twist that changes everything. Scientists aren't just watching this happen. They're asking a question that would have seemed insane just a century ago. Can we stop it? The answer is maybe. Not by stopping the sun, that's impossible. But by moving. Theoretical proposals already exist for something called stellar engineering, using gravitational tugs from asteroids or spacecraft to slowly nudge Earth's orbit outward over millions of years, keeping pace with the sun's increasing brightness, buying more time. There's also the idea of Dyson spheres, megastructures built around the sun to capture and regulate its energy output. Science fiction? Maybe. But every technology you use today was science fiction once. And here's the thing that really gets me. 1 billion years is an incomprehensibly long time. Modern humans have existed for maybe 300,000 years. In 300,000 years, we went from stone tools to quantum computers. Imagine what we could do with 1 billion. If we don't destroy ourselves first, and that's a big if, the descendants of humanity could be a civilization so advanced they wouldn't even recognize us as their ancestors. They might not need Earth at all. They might have seeded entire galaxies. Or maybe, and this is the version that keeps physicists up at night, maybe they find a way to travel to a new star, to start over, to carry the flame of life forward into the next chapter of the universe. So, here we are, standing on a small rock, orbiting a medium-sized star. In one of hundreds of billions of galaxies, and that star, our star, is dying, slowly, predictably, inevitably, but also beautifully. Because the atoms in your body right now, they were forged in the heart of a star that died long before the sun was born. You are literally made of stardust. And when the sun finally dies, when it breathes its last light into a glowing nebula and collapses into silence, those atoms don't disappear. They scatter. They drift through the galaxy for millions of years. And one day, in some distant corner of the universe, around some young star we can't even imagine, they become something new. Maybe something that breathes. Maybe something that looks up at its sky and wonders where it came from. The sun will die. But the story? The story keeps going. If this video made you feel something, even a little bit of that cosmic vertigo, hit subscribe. Because we're just getting started. Drop a comment. Does knowing the sun will die one day change how you think about life? I read every single one. And share this with someone who needs a little perspective today. Because sometimes the biggest problems in your life look a lot smaller when you zoom all the way out. See you in the next one.